This is a lecture on A-2, zTest for the mean. This is the first lecture on hypothesis testing of the series of many hypothesis different tests. There's two methods. One is called the traditional method and the other one is called the p-value method. We will favor the p-value method because it jumps out of the calculator a bit faster. But what we need to do is we need to start with the traditional method. That way you can orient yourself on what exactly is going on and have a better understanding of what is going on. So in order for me to start 8-2 is I need to have assumptions. What we're doing is the z-test, and it has a test statistic given by the formula z is equal to x bar minus the mu divided by sigma over the square root of n. This is going to be my test statistic. This is the formula that is programmed into your calculator under the button, the z-test. The x bar is a sample mean. The mu is the hypothesized population mean. Sigma is the population standard deviation. And n is the sample size. What we need to do, the assumptions in order to use the z-test is n is greater than or equal to 30, or you have a normal distribution, population is normally distributed. And another big thing is sigma is known. If the two assumptions are met, you can go ahead and use the z-test. My first example is example A-3. A researcher believes that the mean age of medical doctors in a large hospital system is older than the average age of doctors in the United States, which is 46. Assume the population's standard deviation is 4.2 years. I think this is extra. Assume the population standard deviation is 4.2 years. A random sample of 30 doctors from the system is selected and the mean age of the sample is 48.6. Test the claim at alpha 0.05. What we need to do is we need to go through all of the steps of the hypothesis test. Step number 1. Now I will outline the steps for you, and this will be given to you on a test as a instruction handout. Step 1. You need to state the hypotheses, meaning the null hypothesis and the alternative hypothesis. A researcher believes that the mean, wrong color, mean age of the medical doctor in the large hospital is older than the average age, which is 46. So the highlighted the highlighted words that I have right now will identify the null hypothesis. You state the null hypothesis is it must include the parameter that you're dealing with. In this case, we are hypothesizing about a mean. And it must have an equal sign and the age of the presumed population. Then you need to state the alternative hypothesis. The alternative hypothesis needs to include the same information, mu and the 46, and something that we're trying to state. So a researcher believes that the mean age of the medical doctor is larger. Oh, I'm sorry. In the large hospital system is older. That's the word I wanted to use. The older means that it's actually greater than 46, and this is what he's trying to claim. So your book makes a difference. Where is your claim? Because depending on the claim, the type 1 type 2 severity of the severity of type 1 type 2 error changes. So if your claim is an alternative hypothesis, type 1 error is your biggest concern, and if your claim is in the null hypothesis, then your type 2 error is your big concern. Step number 2 is find the critical values and compute the test statistic. So the test statistic, that is your z is equal to all of that good stuff, x bar minus mu divided by sigma over the square root of n. This will be done with a calculator, but if you'd like to try, you can try this at least once without the use of a calculator. What we need to do is we need to write down the necessary statistics in order to run the test. Assume the population standard deviation is 4.2 years. So they gave me a standard deviation of a population of 4.2. So that means that they gave me a sigma. They also gave me a random sample of 30 doctors. And the mean age of a sample, meaning x bar, is at 48.6. In order to do a traditional method, we need to find the critical value. In order to find the critical value, this is the number that you look up. I'm drawing this as a z, meaning right in the middle is going to be my 0. I need to identify the test that we're using. If this is a test for the population mean, or inferencing about population mean with sigma known, by definition, what you're using is a z-test. You need to state the name of a test and the necessary statistics in order to run the test. So this is what I just did right over here. That's my necessary statistics. And this is the name of a test. If the book is asking for critical values, we'll find critical values, and right here under under the alternative hypothesis, you can tell whether the test is a one-tailed test or a two-tailed test. If you have a greater than sign, you know that it's a one-tailed test, and you know that it's a right tail. So what I can do is I can draw this picture looking like this to identify the critical region as the shaded region. And my alpha is 0.05, so this area has to be 5%. In order for me to look up this the critical value, I need to look up the z-score that corresponds to the bottom 95%. In order for me to do this, I can type in inverse norm, the bottom 95%, comma 0, comma 1, and this will spit out a z. The z that corresponds to this, move the error just a little bit, is 1.645. Then I can take all of the values that were given to me in the original problem and plug it into my calculator and find the z. In this case, the z will be 3.38. What you can do is you can decide where the 3.39. So the 3.39 will fall into either the critical region or a non-critical region. Notice that if this is my 0, 1.645 is the number to cut off the critical region. 3.39 falls inside the critical region. If I'm inside the critical region, the result of the test is reject the null hypothesis. You must state it as a complete sentence, not like the book is showing in the answers at the end of the book. I'm looking for complete sentences. Reject the null hypothesis. You can either write null hypothesis in English, or you could write null hypothesis using math, symbology. So reject the null hypothesis, and then you have to write down the sentence that represents what it is that you're rejecting. So if the original claim was mu is equal to 46, you can then state, there is enough evidence to support the claim that the average age of the doctor in the system is greater than the national average of 46. This is what the book is stating. So if I manage to reject the null hypothesis, I am rejecting the null hypothesis in favor of the alternative hypothesis, which happens to be the claim. So there is enough evidence to support the claim that the average age of a doctor and then you're basically copying what the original problem is saying in the system is greater than the national average of 46. All of the steps of the hypothesis test must be met. We can now continue to the next problem. This is example 8-5 in your book. A researcher wishes to test the claim that the average cost of tuition and fees at the 4 years public college is greater than $5,700. I think I skipped the problem. Why don't I end this video with this example, and we're going to continue on the next example, comparing the traditional method with the p-value method. I'll do this on the next video.